Welcome to Siafunda once more. I am Mr. Spusiso Kanyile. I want us to do under Algebra the topic called Exponents and Surds for our grade 11s. It is important that we should understand our exponential rules, our exponential laws. The first law that I want us to look at is that suppose you've got a to the power b times a to the power c. What is the law saying here? When you multiply powers, number one, if I've got a number 2 to the power 3, this value there is called the exponent. And this value here is called the base. And the only number together, we refer to it as a power. This whole number is called the power. This one only is called an exponent. This one is called the base. This is the exponent, this is the base, this is the power. This is the exponent, this is the base, this is the power. When you look at these two powers, what is it that we notice? What is the base of this power? It is A. And what is the base of this power? It is also A. Now the rule says, if we multiply powers with the same base, you add the exponents. Meaning that the answer here will be A to the power B plus C. So this rule says, if you multiply powers with the same base, you add the exponents. So if this A to the power B, A to the power C, because we are multiplying, all you need to do there is to add the exponents. For example, if we've got 2, we just use x. If we've got x to the power 2 times x to the power 3, so the solution here will be, because this power and this power have the same base, all that I need to do is to add the exponents. So this will be x to the power 2 plus 3, which will give us x to the power 5. So that's another very important exponential law that we must learn. The second one, the second rule, it's a law of quotient when we divide. If we've got a to the power b divided by a to the power c, there we're multiplying, but here we are dividing the quotient. If we've got a to the power b divided by a to the power c, since we're dividing powers with the same base, so this will be equals to a to the power b minus c. You subtract the exponents. If you've got a to the power b divided by a to the power c, all that you need to do there is to subtract the exponents. This is another important rule, my exponents. Another important rule that is important is what we call raising a power to a power, the third one. It says if I've got x to the power x times y, all this is raised to the power p. The rule says this is the same as, this x is to the power p, and this y is also to the power p. So it says that this will be the same as x to the power p times y to the power p. Both of them are to the power p. Both of them are to the power p. So this is what we call raising a power to a power. Right. Another important exponential rule is that when you divide exactly, if you've got x over y, and they're also all to the power p, so this can be written as this x here is to the power p, and the y is also to the power p. That is also very important. It's the same thing as well when you divide as well. And there's another one that we must all know. Let's look at this one. If I've got x squared divided by x squared, what do you think the answer will be? This is exactly the same as this one. So what the answer is, if I've got 2 over 2, what is the answer? It's 1. 5 over 5 is 1. So if we divide something with the same thing, it will be equals to 1. So this over this, it is equal to 1. We know that. Now watch here. It can also do it, use the exponents to solve the same thing, using the second rule, this rule. If we've got x to the power 2, I subtract 2 because I'm dividing, minus 2. This then will be equals to x to the power. What is 2 minus 2? It is 0. But I know originally that this is equals to 1. Therefore, this also must be equals to 1. So it is important that we should note that any number to the power 0 is 1. We took it from that law, Yama exponents, as Fundisa from the second law of quotient. If you divide this, it will keep A and will say B minus C. That's what we are doing here. We know that this over this should be equals to 1, but when we use exponential laws, it becomes 2 minus 2. 2 minus 2, which will give us 2 minus 2 is 0. Any number to the power 0, now we know that it is 1 from that rule. I want us to look at a few problems on how we solve these problems in an exam setting. Let's look at the first one, the second one, then we move on. Right, what is it that we have there? We've got 9 times 2 raised to the power x minus 1 equals to 2 times 3 to the power x. Look here, the base is 2 here, the base is 3 here. This is 2, but this is not 2. We can change this into 3 as well. This is 3 to the power 2 times 2 to the power x. This is the same as times 2 to the power minus 1. Because when you multiply powers with the same base, you add the exponents. I'm applying just rule 1. Before it was like this, it was separated like this one. This is the same as, this is 2 times 3 to the power x. Okay, let's look at what we have there. All right. Remember, the instruction is we must solve for x. We must find the value of x here. However, x is on the left-hand side, and x is also on the right-hand side. How can we bring it on the same side? It means that I've got to divide here by 3 to the power x. What I do this side, I've got to do it on this other side. So I also divide by 3 to the power x this side. Okay, that's what we have now. I can see that this will go with that one. So these x's are together now. How do I get rid of this? How do I get rid of 3 to the power 2? I've got, this is 9, this is 9. In other words, if I've got 9 here, I've got to divide by 9 on both sides. So in other words, this side I've got to divide by 9 as well. Let me write it first. I've got 3 to the power 2 times 2 to the power x times, what is this? 2 to the power minus 1. It is half. It is 1 over 2. 2 to the power minus 1 is 1 over 2. If I've got 2 to the power minus 1, if I want to make it positive, it is 1 over 2 to the power 1, which is 1 over 2. If I've got 3, okay, let me just use the same number. If I've got 2 to the power minus 3, this is the same as, if I want to make it positive, I push 1 on top over 2 to the power 3. Now this is positive. This is positive. This is positive now. So this is the same as 1 over 2 to the power 3 is 8. So you must be able to see that. So if I've got 2 to the power minus 1, it is the same as 1 over 2 to the power 1, which is 1 over 2. Right, this is all over now, 3 to the power x. This then becomes, what do we have on the other side? We've got 2. Right, that's what we have. Let's work this thing out. I want to divide by 9 on both sides. So this side, if I divide this by 9, in other words, if I want to get rid of this one, I've got to divide by 9 this side and divide by 9 that side. So this is divided by 9 times, or I divide by both of this, 9 and half. 9 times 1 over 2. Right, I'll divide by that. What do I have this side? I divided by 9, it went. Divide by half, it went. So this is what we have now. We've got 2 to the power x over 3 to the power x, which is equals to. What do we have this side? Okay, I divide by, if I want to change, this is the same as 9 over, not 9, but 2. This is 2 over, what is 9 times half? What is 9 times half? It is half of 9. It is 4 and a half. So this is just 2 over 4 and a half. Okay, let's just work it out so that we'll see it. This is the same as 9 over 1. So it's 9 times 1, it is 9. This is 1 times 2, this is 2. That's what we have, 9 over 2. This thing can be worked further. While I'm working that one further, I see something here. If you remember this rule, x, okay, if we've got x to the power p and y to the power p, if you want to make it 1, you can make it in that form. But in this case, we've got this 2 is to the power x, and this 3 is to the power x, we can have it as 1. This can be 2 over 3, all raised to the power x. Both of them are raised to the power x. You can put them in bracket and express it in that way. Remember what we have on the other side. Let's check what we have. We've got this 2 times, let's change the sign into times. If we change the sign into times, the 2 goes on top, the 9 goes below. So it's going to be 2 over 9. That's what we have here. If you apply this rules multiplication, if you change the sign, division sign into multiplication sign, it means that the 2 should go on top and 9 go below. So that's what we have there. We change that sign into times. Instead of division sign, we change it into times. If you do that, you interchange the fraction. The 2 goes on top, the 9 goes below. That's what we have. Let's see what we have now. This side, we've got 2 over 3 raised to the power x. What do we have on the other side? So we've got 2 over 3 raised to the power x. It is the same as, what is 2 times 2? It is 4 over 9. Oops, that's what we have. How do you solve this? All right, let's move on nevertheless. Let's continue this side. Let me just take this space. Right. This is where we are now. We want to move into finding the value of x. Okay. We can find it in 2 ways. We can either use our logs or we can just use our exponents. Look here. This is 2 over 3. Can I have that as 2 over 3? Because when we are solving for x, we work on making the bases the same if the x is an exponent. If x is the base, we make on making the exponents the same. In this case, since our x is the exponent, we want to make the bases the same. Let's do that. Can I make this, how can I write this in another form? So this side, I've got 2 over 3 raised to the power x, the same as, what is this? This is, how can I write 4 in exponential form? It is 2 squared. And how can I write 9 in exponential form? It will be 3 squared. Both of them are raised to the power 2. So how can I write this in the law that I've shown that side? So this will be 2 over 3 raised to the power x, and this is equals to 2 over 3, and both of them are raised to the power 2. That's what we wanted to see. This base is the same, exactly the same as this base. The law says if the bases are the same, therefore the exponents will also be the same. Therefore, since these bases are the same, then the exponents will be the same. Therefore, x will be equals to 2. These are the types of exponents that we must get used to it, especially at grade 11, because they come out a lot, where you apply your exponential laws. Right, let's look at this next one. This includes both the exponents and surds. This was just only the exponents. Where there are square roots and cube roots, we call them surds. Hence the topic, exponents and surds. Right, this one is in exponential form, surd form, surd form. Right, let's work it out together. What is important about these exponents? If you want to understand them better, you also have to understand, especially our sets. Surds has to do with perfect squares. One times 1 is equals to 1. 2 times 2 is equals to 4. 3 times 3 is equals to 9. 4 times 4 is equal to 16. Why am I writing this? I'm talking about perfect squares. So this number is called a perfect square. This is also a perfect square. This is a perfect square. This is a perfect square. So the smallest perfect square is 1. How did we get 1? 1 times 1, followed by 9. In other words, what is the square root of 4? It is 2. What is the square root of 9? It is 3. Square root of 16, it is 4. So what is the next perfect square after 16? It will be 25. After 25, 36, and so on and so forth. So it is important that we must have an idea of perfect squares when we deal with the exponents. So it is also with sets. It is also important to note that square root of 3 times square root of 3, it is equals to 3. This becomes very important to note such. So square root of x times square root of x, it will be equals to x. Now, let's look at this one. Because I want to find the value of x here. If I've got 48, I've got 3. Now, this 3 is give me an idea that here, if I want to have square root of 3 times square root of 3, so I must have 3 under the square root. And when we multiply this, sum must be a perfect square. Let's do this thing. We break this number such that there is a perfect square, n3. So this then will be equal to square root of 3 times. How can I break that? It's 3 times what will give us 48? 3 times 16. And 16 is a perfect square. So it's a piece of cake. This is minus. Let's look at this one. It is important to note that we work with this better if the bases are the same, if the bases are the same, if the bases are the same. So we'll try and make the bases the same in the other one. What is the base of this one? It is 4. And what is the base of this one? It is 2. So we can either make both bases 4 or both of them 2. So this is 4. What is 2 to the power 2? It is also 4. So we can make those bases the same. We can either make this 4s or both of them 2s. If we make them both 4s, this will be 4 to the power x because this is plus. So before it was plus, it was times 4 to the power 1. Because if the bases are the same, you added the exponents to get x plus 1. So that's where it came from. But that one is divided by something else. It is also divided by, can I make this 4? Yes, we can. What is 2 to the power 2? It is 4, but next to it there is x. So that's what we have. It's a piece of cake this side. All the bases are the same now. We've got 3 and we've got a perfect square. Let's work this thing out. What is square root of 3 times square root of 3? In other words, this is square root of 3 and square root of 16. In other words, this is, if I do this one, if I take the 16 out of the square root sign, it will be 4. Next to it, it is square root of 3, but multiplied by with the other square root of 3. So this is the first square root of 3, this is another one, and this is 4, square root of 16, which is 4 there. Minus. You can see that 4 to the power x can go with 4 to the power x. So this whole thing is minus 4, just minus 4. Right, let's move on. What do we have now? What is square root of 3 times square root of 3? It is equals to 3. So this is the same as 4 times 3 minus 4. So this will eventually give us, what is 4 times 3? It is 12. 12 minus 8, minus 4, it is 8. So that's the solution there. Thank you.